Okay, so what I'd like you to do now, you all have drawn an ellipse. I want you to compare ellipses. Okay, what happens? How are your ellipses different? Some of you put your brads closer together, some of you put yours further apart. So what's the difference in your shapes? Go ahead and talk about it.
I can't really compare mine. It's in
Yeah, it's not a perfect. Okay, so part 2, you guys have some really nice ellipses here. I want to, can I see yours? I'm going to show you pod 2's ellipses. Okay? They did some nice work here. Now, tell me, pod 2, what's the difference between these two? So these had brads further apart, these had closer together. What's the difference in their shape, pod 2?
Well,
Stretches it as the things are further apart.
Okay, so this one looks more circular. This one stretches out more. Okay, so the further apart your brads, the more what?
ovular.
The more ovular it's going to be. Okay. So let's talk about what an ellipse is. Okay. Now, what was true? We used that dental floss to trace it. So what was true about your dental floss as you were tracing it around? Did your dental floss ever change length? Like as you traced it, you had the same dental floss, the slack just got longer on one side, shorter on the other as you traced around, right? But your dental floss stayed the same shape. Okay? So basically you created an ellipse using the property of an ellipse. Okay? That dental floss was the same length the whole time. We just changed where it was cornered, I guess if you will, like on your pencil. Okay, the definition of an ellipse is this. It's the set of all points whose sum of the distances from 2 points is constant. So don't write anything down yet. Okay, this is your dental floss. Your dental floss never changed. Okay, it changed like where it was cornered, but the length of it never changed. So your dental floss or these two distances always add up to the same length. Okay? Your brads, we call those two foci. One focus, plural, two foci. All right? So go ahead and write down your definition. And if you want to, if you plan on keeping your ellipse, you can label the holes in your paper as the foci. Okay, so the geometric definition is that the distance from any point on that ellipse, when you take the two distances from the foci, they'll always add together to be the same thing. Okay, I'll come back to this. But I want to give you a little demonstration. So we did the dental floss. Okay? Here's that same kind of thing. So do you see how I have a point right here? And this red distance and this blue distance are calculating the distances to each foci. And here I'm adding up those two distances. What happens as I twist this around? It equals the same thing. Those distances change, but they always add up to the same thing. My dental floss never changes. Okay? All right. Now, do you notice how, okay, we didn't make perfect circles. One side is longer than the other, if you will. Okay? What we can do is we can draw an axis. So your foci are sitting on a line on your paper. That is what we call the major axis because that's the longer side of your ellipse. Okay, this is the major axis. And we call these endpoints vertex points or vertices. Okay. The shorter side of your ellipse, if you draw a line perpendicular through what we're going to call the center, okay, that's going to be our minor axis. So if you want to label anything on your yellow ellipse, the point in between your two holes would be the center. Okay. The points on that line that lie on your ellipse, those would be your vertex points. And then you could draw a line through your center perpendicular for your minor axis if you want to. Okay. When we go to actually draw these ellipses on graph paper, you're going to need to know the center, and everything's going to be based off that center. We're going to plot the foci, we're going to plot the vertices, and then I'll also have you plot these 2 points right here as well. Okay. All right. Now, when we talked about parabolas, we had parabolas that opened vertically and we had parabolas that opened horizontally. Okay? Same kind of thing is happening with ellipses. We can either have ellipses that are longer horizontally or ellipses that are longer vertically. Okay? So, first of all, how do we tell that it is an ellipse? Second of all, how do we tell which is which? So, when we talked about parabolas, we either had an x squared or a y squared. This time, we're going to have both an x squared and a y squared, and they both need to be positive. Okay? So, let's talk first about a horizontal ellipse. Okay? Here is the standard form for an ellipse. So the x and the y are going to be squared, and they both are positive. Notice how this standard equation equals 1. Now you're writing down that A is bigger than B. Okay, that's always going to be true for an ellipse. That's talking about this guy right here. If the bigger denominator is associated with the x, that means it is longer horizontally. If the bigger number is associated with the x, it is longer horizontally. Now, this guy is our center right here. Right? Your vertex points are going to be A away from your center. Okay? I want to write it like that. on here. I want to write it like that instead of giving you a weird formula. I want you to know that your vertices, sometimes I'll call those your major vertices, they're going to be A away from the center. Okay? And then these points right here, your book's not going to ask you to label them, but I will. I'm going to call these our minor vertices. They are going to be B away from the center. Okay. Okay. Now, the foci will always have to lie on the major axis. So if it's a horizontal ellipse, the foci have to be horizontal from the center. Okay? Each focus, or what we call the foci, they are going to be C away from the center. And you don't know how to find C yet, but I promise I will tell you. But the foci are going to be C away. So we have three numbers we have to identify. Before that, we have to figure out what the center is. Then we have to identify A, B, and C in order to determine where the foci and vertices are. Okay. Take 5 seconds, 10 seconds, and make a prediction about what's going to be different in the equation if this is going to be a vertical ellipse. 10 seconds, go. Pause 3. That's you.
Is B gonna be bigger than
I like where you're thinking, but instead of B being bigger than A is always going to be the biggest. We're just going to put it with the Y. Okay, so you were thinking this along the correct path. We're just going to make it easier on ourselves, and we're going to always say that A is the bigger number. And so if the bigger number is underneath the Y, it's going to be vertical. If the bigger number is underneath the X, it's going to be horizontal. Okay, everything's the same. We're just moving vertically. Okay, so our major axis is now vertical, but our vertices are still A away. Our foci are still C away, and our minor vertices are still B away. Couple things I want to talk about before we actually go to graph one of these. Okay? First thing. Oh, there's my screenshot. The major axis. Layton, how long is the major axis? Total.
2A?
Very good. The center to the vertex is A, so if we look at the entire major axis, it has length 2A. Which means, Sean, how long is the minor axis? Okay, he spouted off a lot of things. Does somebody want to comment on which one is correct?
2B.
You got it. What happens if A and B are the same? Then we have a circle. And what would be true if you wanted to make a circle using our brads and dental floss? Where would you have had to put the brads? Right next to each other? Or together, right? essentially your foci become the center if you want a circle. Okay? Now you're all on the edge of your seat. Mrs. Homan, how do we find that C value for our foci? I will tell you it is this. If we have time, I'll come back to this and show you why C squared is A squared minus B squared, but it's Wednesday and we have 5 less minutes, and so I don't want to eat up our time with that, because I still like to come back and answer questions on the homework. Okay? So if we have time, either today or tomorrow, I'll come back and tell you why this is true. Okay? Now, we have one more vocabulary word. Some of your circles were more ovular than the others. That's the word that Leighton threw out there. Ovular is what you said, I think. All right? Instead of saying ovular, we comment on the eccentricity. Okay? Eccentricity is a measure that tells us how oval we are. Okay? So if we take C over A, we get a number that's always going to be between 0 and 1. What kind of number will give us a more circular ellipse? Closer to 0 or closer to 1? You say closer to what? What? Okay, so if we're taking C divided by A, that means that C is very close to the same length as A. Does that make sense? Right. Well, that A just looks like a C. Okay. Let me bring back our pictures here. This is more circular. This is more oval. The more circular one had foci that are further or closer? Closer. Okay? So if we take C over A here and C over A here, which one's going to be closer to 1? Okay, do you agree that C is closer to the length of A in this example than in this example? The foci are closer to the vertices here, which means their ratio is going to be closer to 1. Our C is significantly smaller than our A here, which means our fraction is going to be a lot smaller. Okay, so the closer that we are to 0, the more circular our ellipse is. Okay. All right. Let's get to it. Please write down this example. X squared plus 4y squared plus 6x minus 8y plus 9 equals 0. Okay. I am giving you an ellipse in the general form. Okay. We know it is an ellipse. Why, Kayla?
Because around the circle.
Okay, what about that equation tells us that it's not a parabola? Okay, good. Both the x and y are squared, and because they're both positive, we know it's going to be an ellipse. Okay, Friday we'll talk about when they're not both positive. Okay, so we know we need x minus h squared, and we know we need y minus k squared. All right, so what are we going to have to do to get an x minus h squared? Complete the square. And what are we going to have to do to get a y minus k squared? Okay, so we have to complete the square twice in this example. Okay, not a problem because we're rock stars at it. So what I'm going to do is I am going to group the x's together so that I can complete the square. I'm going to need more room than that. And then I'm going to group my y's together, but notice how y squared has a coefficient of 4, so what are we going to have to do with that? Factor it out. So I have y squared minus 2y. Okay. And if we go back to standard form, just hang tight for a second. We want an x squared, we want y squared, and then we want it equal to 1. So what we're going to do, any constants, we're going to just put over on the other side. So I'm going to subtract over this 9. And then to balance our equation, we know we're going to have to add whatever we add to the left side. Okay? So Courtney, what completes our square right here? 9. So I'm going to add 9 to both sides. All right? B, what completes our square right here? 1. But what number are we really adding? 4. So I'm going to add 4 over here. So what we have is x plus 3, the quantity squared, plus 4 times y minus 1, the quantity squared, equals 4. Now this is not in standard form yet. What do we need the right side to be set equal to? It needs to be set equal to 1. So what are we going to have to do to make sure that is a 1? We're going to have to divide both sides by 4. So our standard form equation is x plus 3, the quantity squared, over 4, plus, I'm going to write this as y minus 1, the quantity squared, over 1, equals 1. Okay. Okay, Maddie, which one's the biggest denominator? Okay, 4 is bigger than 1. And since the 4 is underneath the x, we know that this is a horizontal ellipse. All right? Now let's identify some things. Sarah, what is our center? Okay, let's go back here. Our center is HK. Here's H and K in our equation. All right? Yes. -3, 1. Okay. Now, since 4 is the bigger number, 4 is going to be our A squared. Right? So what's our A value? Okay. So A is 2. I'm going to make a little note. A is 2. And if this is B squared, that means B is 1. All right. So we said this is a horizontal ellipse, which means our A value, that's how we're going to get our vertices. Yes.
How do you define it?
Our denominator is A squared. So if this is 4, A is 2. So what we're going to do, we're going to move horizontally 2 from our center. So our vertices are going to be, well, I graphed -1, 1 and -5, 1. Then to get our minor axis, we're going to use B. So we're going to go up 1 and down 1 from the center to get what I'm going to just have you label as minor vertices. The book does not talk about minor vertices. I just like you to actually write them down so I can see that you moved B away from the center. Okay, so we plotted points at -2, 0 and -2, 2. So those 4 points give you the shape of your ellipse. What? Oh, thanks. I can't count this morning. And then finally we need our foci. I had you write down that c squared is a squared minus b squared. Okay, well, a squared is 4 and b squared is 1. So c squared is 3. Which means c is radical 3. I'm going to tell you right now, not very often will your c be a rational number. Oftentimes it's going to be a radical. Okay? But that is okay. Radical 3. 3 is more than 1, but less than 4. So radical 3 is going to be between what two numbers? 1 and 2. Okay, radical 4 would be 2. It's less than that. So we're just going to plot some points a little bit more than 1 away for our foci. Now, I do want you to label these, and this is how I want you to do it. Okay? Since we moved horizontally from our center, okay, we moved from -3 and we went right radical 3, and our y value stayed as 1. We also, moved left radical 3 from our center, but our y value stayed at 1. So that is how I would want you to write your foci. If it asks for eccentricity, all you have to do is take c divided by a, and that's your eccentricity. Okay. Any questions? Kind of letting this soak in a little bit. Ready for another example? We'll just do one more. Okay. 9x squared plus 4y squared plus 36x minus 8y plus 4 equals 0. Okay. We know it's not a parabola. Why? Okay, x and y are both squared, and since they're both positive, we know we're going to have an ellipse. Okay, now this is in general form. We need the x minus h squared, and we need the y minus k squared. So we're going to have to complete the square. Okay, let's talk about our x's. X squared has a coefficient of 9. That's not okay, so we're going to have to factor it out. So when I group it with this 36x, what am I really going to write? Okay. That way we can complete the square. All right. Then we have 4y squared. That 4 is not okay, so I'm going to factor it out. And when I group it with the negative 8y, we also have to factor the 4 out of there. So negative 2y. Okay. It's going to be easier to go ahead and move any constant to the other side. Because we're going to need that right side to eventually be 1. So whatever's over there, we'll just divide by it. Okay. So Josie, what completes the square here? 4. Well, we're really adding 36. Great. Cassie, what completes the square here? 1, but we're really adding 4. So what we have is 9 times x plus 2, the quantity squared, plus 4 times y minus 1, the quantity squared, equals 36. Okay, those numbers look quite nice. Okay, and we want fractions, so it's good that that right side is a larger number. Okay. So since the right side needs to be 1, what do we need to do to both sides? Divide by 36. So 9 divided by 36 is a 4, so we're going to write x plus 2 squared over 4. 4 divided by 36 is 9, so we're going to write y minus 1 squared over 9 equals 1. Okay. So we have an ellipse. Amanda, is this a vertical or horizontal ellipse?
Vertical,
Amanda says vertical. Morgan, why is it vertical?
because, A's under Y.
Okay, a is under the y squared, or if you want to think of it, the bigger number is associated with the y squared. Okay, so this is vertical. All right, here we go. Our center. Grant, where's our center?
Negative 2, 1.
Negative 2, 1. 9 is the bigger number, so that's a squared. So I'm going to go ahead and make a note to myself that a would be
3.
3. 4 is a smaller number, that's b squared, so I'm going to make a note that b is 2. We determined this is a vertical ellipse. So when we plot our vertices, they will be vertical, and how far away will they be? Brianna? They'll be 3 away. So our vertices are negative 2, 4, and negative 2, negative 2. Our minor axis, those points are going to be B away. So we're going to move 2 away, and I'm just going to have you label those as minor vertices. You're not going to see that in the book, remember. Maggie, what was that equation to find C?
C squared equals A squared minus B squared.
Okay, so if C squared is A squared minus B squared, then that means C squared is 5. So C is radical 5. And our foci, that's the distance from the center. So radical 5, if we were going to approximate it, we would say that that's a little bit more than 2, because it's just over radical 4, which is 2. Oh, I should probably draw my ellipse, huh? So a little bit more than 2 are our foci. And when you go to write those down, we moved vertically. Our x-coordinate did not change. So our x-coordinate stayed as negative 2, but from 1 we went up radical 5. And from 1 we went down radical 5. Okay, you have about the same amount of homework tonight. You have to do your homework, okay? If you can't do ellipses, you cannot do hyperbolas. So if you do your homework tonight, hyperbolas, piece of cake, all right? We have a few minutes left, so I will entertain questions on homework if we have them. If we can't get through everything, I know we'll have extra time tomorrow. So does anybody have a problem that we need to talk about from last night's homework? Yeah.
Number 62, like the answer.
The answer for 62 is on my page y equals negative 1 over 640 x squared until part B is 18.
Can we go over that?
Mhm.
I did not understand.
Okay, so essentially, this is your vertex, and you could say, like, if you wanted to label this as like 0, 0 as your vertex, then since this is 32 feet, and we know our height was 0.4 feet, then you could label this as 16, comma, negative 0.4. Negative. And this point we could label as negative 16, negative 0.4, right? Because we're down 0.4, so that's how I got the y coordinate. And since from here to here is 32 feet, then from the center, we're 16 feet. And so if you use this as your vertex and this as a point, you can write your equation. Okay? And so then if it asks how far from the center of the road, of the surface, 0.1 feet, then basically what you're doing for part B is it's giving you a y coordinate of 0.1, so you can plug that into your equation to figure out what the x coordinate is. Okay? Amanda, does that make sense?
I just didn't have it set up right.
Okay. And really, you could choose any point to be your vertex, but 0, 0 is. All right, please make sure your brass are back in the bag and everything's laying on top of the yellow paper.